Hey everyone, this is Aniket Chabra. I am one of the co-instructor in this course, which Malti is leading. So Malti is a seasoned product lead, product head in a couple of organizations. She has spent time, and currently she is running this initiative where the objective or the idea is to educate people in the AI product management space. I'm working with her on this initiative as a co-instructor. So she has kept this session, send you the invites, and thanks for joining. The session. Today's session is more about the on the fundamentals of AI product management. Most of you people, like if you have, are reading about AI, you would definitely read about memory as a concept, right? So we have been taking these community sessions for quite a long time now, and this is one of the fundamental concept session that we wanted to conduct. It'll be less on the coding side or technical, demo side, which we have been giving for the past few sessions. But this is more on the conceptual strategy, product thinking side. Like how do we think about like the AI product foundational, AI product foundations. So let's unpack the memory, the context management, the prompt engineering in detail. You would have definitely heard, these concepts in several videos, online or let's say if you're reading some blogs. So the idea is to, grasp, give you more practical knowledge, implementable knowledge, implementation knowledge, which you can like the idea would be that you take away important conceptual learning from here, which will help you to, let's say, help you in building your product journey, AI product journey. Yeah. So it's a very important concept called AI products memory, right? So if you heard about context engineering, it's one of the core, component of the context engineering. Like the way context engineering works, it is based on memory plus prompt plus context management, etc. So it's a key pillar there, and especially when you're building agents, right? The software products that currently, organizations are building. This is one of the important platform layer that we develop, right? It's part of your platform product strategy. If you are working in the AI product era, if you're working in non-AI product era but want to move to AI product management, this is one of the core concept, core component of AI product management, or AI product as a platform, right? So we'll talk about like different types of memories. We'll talk about context engineering. We'll talk about token economics, which is token optimization. So, token economics I was talking about, which basically means that token optimization. A lot of organizations in recent past, you would have heard the news also from Microsoft, from Uber, right? So the token cost is becoming a burning issue, and then how to optimize the topics. What is the best way to optimize the tokens? Because token is equivalent to money that you pay, right? Token is basically a cost for the organization, right? And this is again related to the pricing strategy of AI product, right? You sell the product, you sell the software using the AI layer. But let's say if your product is inefficiently built with a high tokens, cost, every query that runs on your platform product, uses a lot of tokens, then actually you're paying a lot of cost. It's so simple, like token equal to cost for you. So the more people use your product, the more tokens they consume, the more costly it becomes to you when sell your product, right? So it's actually opposite from the SaaS strategy that we have seen, right? In the SaaS business, the more people use your product, the network effect or whatever you call it, it's more beneficial to you. You generate more revenue because you charge per user, per seat, whatever. But here the AI products, it's actually the opposite, right? The more people use your product, the more cost you have to bear for the product, right? And you cannot charge infinitely to your customers because there's a lot of competition, quality, competition is there, which means that you also like have to keep optimizing the your platform, your product, to get the maximum out of that. So like people should use that. People must use your product, right? So you cannot have people not using your product, but then again you have to equally optimize the cost of that, and that's where the token strategy, the optimization, token economics comes into picture. And then there are trust risk with the open source models, like how to build them. I can talk about them in few examples. Yeah. So so that's about the overall agenda. Let's move to the main content. So here, if you see, we have been talking about the prompt engineering, right? So you must have been practicing prompt engineering also. So, and the way we use, these prompts are, one way to use them is via, let's say, chatbots, right? Where you ask the question, or you send your query to the chatbot answers, via some model, some LLM behind that chatbot, right? So ChatGPT is one example. It acts as a chatbot. So that's one way of writing your prompt. It's called user prompts, which the prompts that you write are basically user prompts, right? Then the other way is that we actually use chatbots, or we actually, as a platform product manager, we build chatbots with a more contextual information data, right? And that's where the tool calling and rags come into picture, which basically meaning that you have a chatbot which is actually backed by some contextual data, right? Which is your enterprise specific data. It could be some private PI information which you don't want to share. So basically, don't want to expose to LLM via the API call. You basically build that tool call to your internal databases and fetch the data. So your chatbot answers the questions, or in a more enriched way, right? So the idea is that you real time you make these calls to these tool calls to this RAG platform, and RAG sends you the answer. But the question is that every time again you send a query, each time it will keep calling the function call, the tool call, and then get fetching the context from the RAG layer and then send to the user. Right now, is this an efficient way? We're going to discover that today. And the third area that we use AI products is the agentic way. This is the most common, like today's, in the recent times, we have been building these agents. They are like multi-step agents, multi-session agents, right? So now think about agentic layer is what? Like it's basically your LLM, which is your brain of the agent, and on top of it, you have a programming layer. That programming layer is basically, think of this, it is connected to your databases, it is connected to your, let's say, your any repositories that your code bases that you have built, and it is connected to your, let's say, documents and any specific information. It could be, let's say, your emails, very simple, like your Jiras, your Slacks and all. So now think about it. If you ask the LLM a query, right, it has to go through all the tools, fetch the right information wherever it exists, and then send the data to the user, right? So this is how agentic layer works, right? Using the LLM, it generates the answer, generate the best response, and send it to the user, right? But if you think about this way, what's happening here? Like it is accessing all the context that is available. It is accessing your documents, your databases, your, let's say, emails, Slack channels, etc. And the more data sits there in your context, the more heavier your context becomes, right? So then there is a so then how do we handle that? Is something where the memory optimization, or this comes into picture, right? So, and again, the more efficiently so there are two benefits of that. One, of course, you save a lot of cost, right? If you use these architectures, efficiently. The second, you also, improve the accuracy, right? So think about like searching a word from a book versus a chapter, right? There is a high probability that you'll be more accurate when you search for a word in a chapter than a book, right? So similar logic, right? If you're finding some information from a large chunk of text or data, you will have lower probability of success, or accuracy can be impacted. Versus if you're looking for a curated set of content, that information, you will have a higher chance of getting that, in retrieving that particular content, and then also higher chance of accuracy. I hope I'm making sense. Feel free to raise your hand, ask your questions. So then now let's talk about the context window, right? So what is a context window? The context window is that everything that is part of your prompt, right? So let's say, for example, I asked a chatbot a question. My question is, let's say, based on the question, you have a chatbot that is connected to your RAG application, RAG framework, and now it is fetching the context, fetching the information from, let's say, your vector, some databases that is stored there. So now that context, and then your prompt, and there's a system prompt that exists in your LLM, they three become the context for you, right? And that is sent to the LLM every time. So which means that LLM has to process through all the three information. If the context is heavy, your prompt is heavy, system prompt is heavy, the whole system becomes a lot heavier, and then processes the information, right? That's what the context window is all about. So then what happens is that, why people use that? People use that because you technically, it is faster way of fetching the information. Because let's say if you have a real-time chatbot, there could be a latency in function calling. So RAG framework might have some latency, some accuracy challenges. If you know certain things, and if your LLM allows, let's say I have a 1 million context window, 200K context window, I can pass this information in the prompt itself. So the idea is that you basically, the context window is like what LLM model is receiving at the time of, let's say, the query, or whatever your real time interaction with the with the with the LLM AI product, LLMs, right? So then the idea is that it is fast in the moment, which means in the motion, like whatever is going to LLM is actually the context window, like your whole information is context window, right? And then but it is static. It is finite in the sense that at one point in time, you can only send up to the limit of your LLM. Let's say if 1 million token is the limit, you will be able to send only 1 million tokens to the LLM, right? Or your AI product, which I mean, your AI product is built on the LLM. So that's why I'm interchangeably calling AI product an LLM. You can think of like both are the same thing at this point in time. But the idea is that the context window is actually sent to the LLM, and then LLM has to process that 1 million token, or the total number of tokens that you've sent to the product. If you look at, that's a context window at that point in time, the information that LLM sees, right? Versus if I look at the memory, what's the difference between memory is, think of that side like basically it's a separate layer that exists outside of your product, right? So which means it's maybe it could be your database as one of the memory, right? It is durable across sessions, which means that that information is there, will remain as there, and you will fetch the information whichever is relevant for you, right? So retrieving whatever is relevant to you is something that comes from the memory, right? Then now the idea is that you can add a lot of optimization layer on top of it, personalization layer, which means that if you want to curate some information from the memory, you can do that. You can apply the logic. So think of, let's say you're building an agent, which is, let's say, SQL coding agent. That coding agent is hitting your database to get the data. Now, what coding agent will do? First, it'll generate the code. Then it'll run the code on the table and fetches that information on from that table and send it to you. So this is an optimization layer. You're basically, or it could be possible that, let's say, you're creating some part of the data from the main table, and then on top of it you're running the query, right? So that's where the curation part comes into picture. The idea is that it acts like your disk, right? It basically, you're like a hard disk that somewhere it sits. You only use it whenever you need it, otherwise you do a lot of work locally. Think of, in a computer architecture, right? You have a local RAM system and you have a hard disk system. Hard disk gets only hit if you want to hit that, otherwise you process your information locally, right? So that's the difference between context window and the memory. The difference is that context window you don't store. It is a real-time process that happens with the LLM, and memory is actually a storage, right? So so we need to understand the difference between the two, because let's say if you have a requirements to build on, so these are the conceptual things that we need to understand, like what's the difference between memory, or where will you use memory versus where will you use context window, right? So what are the types of memory for the agent, right? So, or for the product. So one is the working memory. So the working memory actually works like a context window, right? So let's say you have some task, it will always happen, right? Currently you're discussing in your prompt, that's a working memory. So think of this as an example of Chat GPT. Whatever you're asking to Chat GPT, right, and you're passing some facts to it, that becomes the memory of for Chat GPT. It's a working memory because it's applicable to only for that session, for that thread, and after that, it's not there. It gets removed, but it is there in the sense that if you ask a next question, the previous question that you asked in the same thread will be available, right? That's a working memory. Then there is an episodic memory. Now, episodic memory are memories where some episode, some event, some incident happened in the past, and you want to retain them for future purpose. For example, let's say, think of this as a ticket escalation agent, right? You have resolved a ticket in the past, right? In a certain way. I mean, the resolution of the ticket was a certain way, and then you're stored, right? You provided the resolution and that worked. You stored that episode, and that's an important, what do you call it? Important issue. Now, what happens is that you can store that in the episodic memory section, and from the episodic memory section, what happens next time if the similar ticket comes or same ticket comes, same issue comes, you can refer to the ticket and get this resolution and send it to the user. It'll be faster, it'll be more efficient. You didn't have to hit, let's say, the whole, storage system. You have actually saved few sections in the episodic memory section, which is part of your vector DB only, right? So, and that you fetch the information from, right? So again, episodic memory, think of this as a special type of category of information that you saved in a database itself, right? Working memory is not part of a database; it is part of your session, the thread that you're currently running. Yeah. No, semantic memory is basically, let's say you have some. So semantic means what? Semantic means basically you are actually mapping some information to some information based on semantics, right? So meaning that similar information, contextual similar information is something that is stored. So the best example for that is knowledge graph. The knowledge graph does what? Knowledge graph is, think of this as, let's take this example that is given here. You are a PM in Bangalore, prefer concise. You are a PM in Bangalore, prefer concise. So what? So think of this as that your relationship is stored in the city Bangalore. You are a PM, right? You are a PM. and then there is a your current city of residence is Bangalore. Now think of this as, let's say, someone else, another PM, right? And if that person has to find another PM in the Bangalore, so that you can map it to that this PM to that PM, right? So this is basically semantic mapping. So which means that and this happens through the knowledge graph, which is also a kind of, you can think of as a, a database, a graph database, I would say, rather than database, and where the entities are connected, the nodes are basically the relationship between the entities, so on and so forth, right? Procedural memory is I think recently you definitely heard about the skills that you have, that you develop in Claude and ChatGPT. Those are actually the procedural memory. These are actually what these are for specific type of task. You can create which are recurring tasks. You can create a skill, right? You can create a playbook that will run whenever you want them to run. You just call that skill, it'll run. So in that skill, there could be, a .md file which can contain information stored locally in the context somewhere, right? And that you fetch in your, let's say, agent itself, and that you are fetching always to send this information. Now the thing is that it's possible that you can have recurring tasks exactly as is where it refers to, but of course you can add instructions if the task is not that not that like similar, not the same. It could be similar, it can refer to that skill still, and still you're optimizing the task that you have. Okay, we have a couple of questions. Let me take up those questions quickly. So 1 minute, I'll go one by one, and then I'll move to the other one. So in an agent, how does a working memory work? All LLM calls are stateless, right? Yes. So what happens is you maintain. So it depends upon your application. As I said, the agentic layer is a programming layer on top of the LLM layer. So let's say if your API calls are stateless to each of the LLMs, then you have to store that information, right? The working memory. You can store. Now there could be an overlap. I'll show the example as well. There could be an overlap between here, let's say, your working memory and cache, like you're basically storing that in cache, and every time if similar query comes, you actually fetch the context via the cache, and then you're sending this information to the user. So it's primarily maintaining the cache, if you think of like working memory, right? So which means that every information that you send as a request to the LLM, you send it via this cache. Okay, this information is this. Now I have this query, help me resolving that. This is the previous context, right? So working memory, think of this as a cache only primarily. The second question is, I hope that answers the question. The second is, isn't that episodic memory a subset of semantic memory? It is. Let me think about it. So episode, yeah. So see, I mean, episode is basically one specific type of memory. It could be anything, right? It could be a semantic, it could be working, it could be, let's say, procedural. It depends upon, so episode is basically a particular episodic is basically a particular episode that happened in the past, and you are referring that to future. It could be any type of, what do you call, a scenario. It could be any incident. The idea is that if that same incident happened in the past, you actually refer that, right? So that'll be my explanation. But if you have anything in your mind, follow up on that, you can ask Suparna.
But everything is semantic, right, Nikhil? I mean, it's basically everything is based on what you are sending. It is all the prompt. It's the text and how it maps back to what you fetch, or like even when you're debugging, you're basically fetching that day's, last week's, whatever, but episodes, right?
Yeah.
Similarly, semantic also, you are fetching a PM in Bangalore.
Yeah.
Prefer concise. I don't understand that, but whatever related to a PM in Bangalore. So these
Yeah.
are stored in certain places, and this is basically a semantic matching is happening, whether a percent from whatever, and then finally you're fetching it.
Yeah.
So isn't it like? I mean, that's what I'm a little
Yeah.
confused.
So
between-
broadly, you can say that way also if you want to say that. But semantic is basically a way of mapping that, right? So there could be other ways of mapping as well. Semantic is one type of mapping, especially when you have multiple entities. You try to map those entities via semantic way. There could be a logical way of fetching this information also from the, from and semantic is one of the logic. Let's say the logic is query based information that you're fetching somewhere,
Okay. Okay.
right? That's
And my-
the
Yeah,
broad
I understand. The second question is working context and the cache which you refer to. The cache is basically the hardware cache, right? Working context is the context which the LLM is handling, whatever is there.
it is the cache that you maintain in your like programming layer that I said. You
Okay,
maintain a cache DB. So there are cache DBs available, right? You maintain that cache in the cache DB.
okay, fine.
Yeah. context engineering, and then like where does the memory fit into this, or the pieces of the memory fit into this overall context engineering? Because again, the idea is that you, as I said, the agentic layer is your programming layer, which uses this context engineering, a concept a lot, which is context management plus engineering, tasks, and then the goal is, let's say, and help agent achieving its goal, right? So first is that you have a system, you have a goal, right, where you actually your prompt where you add the instructions, the roles, right, what exactly the agent is supposed to do, how the output should look like, the output schema and all. That's the system and goal part, like in your agentic flow. Then there is a retrieved memory, which is again like you have a this now this is basically the memory that you have, the memory data that you created in the database, right? So let's take an example of episodic plus semantic facts about, for some information. Now, what happens is that whenever you run a prompt, it is fetching the episodic plus semantic memory wherever it is applicable. Then on top of it, you have a knowledge base or RAG, we call it, which is again a knowledge base, a repository that you create, which will be fetched. Think of this in FAQs, or let's say a documentation where you have saved PDF documentation, you saved somewhere. You want the agent to refer to that whenever the query comes. Then there are tools, which are again, tool means the tool calls, which means the functions or API that you're defining. Let's say how, for a particular query, retrieved memory to be fetched or memory to be retrieved, or knowledge base to be hit, right? So what is the API, is the contracts between the different components here. Then there is a conversation, which is again the, now let's say if you're storing the conversation, previous conversations, you're compressing them, as I said, like in the working memory, it'll be your cache. In the long term, let's say if you want to save the long term, this information for the long term, you can actually save in in a database, right? So you think of this as basically that these are the components of your agentic layer or context, and that sits on the context engineering. So they will become your part of the context. So one is that your prompt, which is the first part, where you define your system, define your goal. Then there is a set of memory. Let's take an example of episodic plus semantic memory. Then you build a knowledge base, which is using a RAG framework. Then there are tools and state currently, what exactly the actions that agents have to take, which are the tool calls, the APIs, etc. Then conversation, if you want to store previous conversations, historical conversation, you can do that as well, right? Which is your working memory, you can say, let's say. Or for the long term also, you can save, long term data in the database, which becomes a long term memory, right? Now this all competes for the finite token. So which means that now the idea is curation is the job, which means that now context engineering is optimizing everything in the programming layer, and or use it efficiently, you can say. So whenever, let's say, you're building a product, right, you have to think through all these components, and the main component is how to use them efficiently, right? So that's where you need help from engineering. You talk to them. You make sure that your use case that you're solving actually requires all these components. If it's not, if your product use case doesn't require that, feel free to exclude it. And that's where the optimization comes, right? And then specifically instruct engineering or work with them closely that how we can optimize it, how we can minimize the token cost that we have, right? Think of this as like episodic memory. What episodes you would like to store somewhere? That is the PM's job to think through. Like which incident you would like to store, which incident you would not like to store. Okay, this we have seen in the past. Let's solve it. Yeah. Now let's take a couple of examples, right? How does ChatGPT work? Think of the ChatGPT, right? So ChatGPT, when we actually use on a day-to-day basis, what it has auto capture, right? So auto capture means a background process synthesis memory across all your chats. You don't have to ask. So there would be a way to optimize the information that ChatGPT has. Like if you're logged into ChatGPT, and if you allow the it is to access your historical chats, your history, it'll save them somewhere and optimize it whenever it requires. So there's a retrieval mechanism, there's a storage mechanism, temporal awareness, right? So it actually, think of this as, let's say if you're going to Singapore in July, if you're writing ChatGPT this, it'll autocorrect it and write it as Singapore. You went to Singapore in July 2026 because it knows the temporal information that you have, right? So it has that information that once the date passes, okay, the person has traveled to Singapore. So think of this as, let's say you were working on a resume on ChatGPT, and then you mentioned that okay, this organization I've joined in 2023, so and so forth. So hopefully, like if you are allowed, it to store the information, whenever you ask the question in the future, it'll be able to tell you like when did you join this organization because it has the temporal information, right? So what happens if you think about it, right? Based on this, what is the benefit? You ChatGPT, think of this as a chatbot. it is able to improve the recall. So 82.8% of factual recall in their internal evals. Now, what is a recall? Recall is basically whenever an information was supposed to be received from the overall knowledge base, it is getting received, or actual information or right information is received. That is what recall is. Your coverage, right? So let's say, for example, you're asking about you went to Singapore in July 2026. That's stored somewhere in your storage, in your memory. Now, if you're able to fetch it correctly during the next query, or when did I go to Singapore? Let's say, then you answer it. Okay, you went to Singapore in July 2026. That's the right answer. It's a 100% recall scenario, right? The other part is that your preference styles, right? So your preferences, your styles. Like a lot of times we interact with ChatGPT, we have a certain style, certain preference. It actually creates a persona for us, which is also a kind of memory for us, for it to store. And then next time when you ask, it tries to answer your question automatically. If you're, let's say, I have a bad habit of writing, I have actually a habit of writing bad prompts, I would say. So my prompts are not that great, right? But it knows that what, because I have had interactions in the past with it a lot of times, it knows what exactly I'm looking for. A lot of time it tries to detect the intent correctly and corrects my prompt automatically and then give me the right answer. So I hardly have had chances where I had to correct my prompt, for a same specific thing that I'm asking for. Mostly I get the answer, right? And this is across users also, but again, because it has enough history, it actually, understand like what kind of questions I do ask, what kind of answers I expect whenever I have based on the interactions that I've had in the past, right? Then there's a time sensitive accuracy, of course, also like depends upon the recall thing, right? So the idea is that the mode isn't that we store chats. It's basically, they have components where like, what to save or what not to save, temporal information, right? And the way they fetch the information becomes the mode, right? It's not only storing like everything, in your, let's say, in the memory. Same thing with the Claude as well, right? So what happens here is that they have built the context in such a way like it's a large 1 million token context, right? So the idea is that the way they store the context is that it's not only like, I mean, so the memory here just not only means the context. It's basically the tool, the way they, if you've seen, let's say, a Claude, a lot of times it stores the data in .md files. That is the preferred way of storing the information, which is again optimization, right? So it's not only about the the memory maintenance, basically the way it fetches the information, the way it stores the information, sorry, .md files, and then accordingly they make the tool for us to extract that information. But very similar, like what we were discussing ChatGPT. So I'll probably not go into detail of this one, but happy to answer any questions if you have. Similar for the coding agents also. Like coding agents, you would have seen like Cursor or let's say Claude Code or Codex, right? So these agents typically maintain, and this has become recently famous as skills, right? So it's called procedural memory, which is skills. So what are the skills? So as I said in the previous slides, it's basically for similar recurring tasks, and especially coding agents, right? They have a lot of codes which can be rewritten, right? Lot of autocorrects, you can say autocompletes can be rewritten because many people, let's say, first of all, like on one project, multiple people work from a team. Let's say 10 people are working. So there could be, scenarios where their code is overlapping. The more overlapping the code is, right? And think about like every time you're hitting the fresh memory, right? You're actually generating the more what do you call it? The more context. And again, the more context means more tokens, right? So the idea is via the skills, one is that it has optimized the information in an MD file, .md file, and that it has to fetch not every time. So the prompt is always concised. So think about like every time you were sharing the same code again, right, to refer to get your correct, corrected version of the code. Now, if its skill is being used, so that you don't have to do now. It knows from the skill that okay, this is what I need to create. This is the information that I have. I usually get when a user asks these kind of questions. So every time it refers that, so that you don't have to every time call with the screenshots with let's say the code examples and all. It has that skill readily available. It does that. Now different tools can have different techniques to implement it. Like for example, there is a mem0 tool which has an open memory concept, right? There are a few tools we're using, let's say MCP servers, memory server like Cursor, Cloud Code, etc. Right? So there are different ways to, or user owned markdown files, also the .md file that I talked about, right? So different ways to implement that, right? So again, I'll not go into details of that. You can read more about it, but the idea is that they're using procedural memory to implement this coding. So whenever if you are building the coding agent, for example, in your software, product development world, you can think of this memory as an important one where you can how you can use skills if every time the problem is coming. Yeah. I'll take one more slide and then pause for the questions. This is the example that I want to talk about, which is let's say there's an agent which is called patch, which resolves a ticket, right? So now how does this agent use the whole context layer, the memory layer efficiently to get to the objective, or let's say the goal of the agent, right? So the first is that let's say you are an autonomous fix agent on a 2 million line some repository, right? There are some Jira tickets where they are, I mean, the memory layers and context engineering do the heavy lifting part, right? So Jira tickets, bugs, issues, codes are there in the memory layer. So first, for example, let's say the ticket comes, right? Goal is that load that ticket. Let's say the checkout 500 seconds on checkout 500 seconds on expired coupons. There's a query on this, and the goal is that this loaded into a working memory. Working memory means in the session. So you have loaded this query in the working session. Then you have now think of this as like recall. So where you have a semantic plus episodic memory. Why episodic memory? Maybe there's a near identical problem fixed in the last quarter, the checkout issue that you're explaining here. If that is the case, then can you refer that? Right. So that's why you're hitting a episodic plus semantic, kind of memory. So episodic is again because the similar episode, and semantic is again because of the maybe there's a mapping required, like this Jira ticket, that Jira ticket sitting somewhere in the repo. Can you establish a connection between them? Then you have to retrieve that, which is where think of this as, let's say, depends upon your logic, which is the context engineering here, pulls only 3 relevant files, not the whole repo. So from the code base, you're only referring the 3 important file based on the semantic plus episodic scenario. This is so technically, or not in a non-technical way, this you have applied a filter and you're fetching the information only from that filter, right? And then how to fix that? You have a procedural memory, which means the skill that you have saved that knows, okay, how to solve this kind of problem because I have done this in the past, because a recurring skill that I have, I actually fix this and then send it to the user. Then open PR and then learn, which basically means writing the fix back to the you know and let's say fixing that part. And now if you have fixed it differently, one more skill gets added in the procedural part. Okay, so that's how the whole loop works. So basically from issue to memory layer to context engineering to updating or like providing the final answer, and then creating a loop of learning as well. It's a feedback loop where you learn, okay, how did you solve this issue? If it's different from the from the steps that you have followed previous time that are saved in the skill, you actually loop it back to the skill, update the skill that you have. Okay, so high level I'll talk about this. So idea is that what exactly you have done. You have one, I'll talk more about this example. Like one is token consumption. So instead of hitting the whole memory, you only hit, let's say, for that particular, so 3 relevant files. Maybe approximately, this is again one example. That is, let's say if you had used, sorry, 26K, plus tokens, if you had done this implementation in a raw way, but now you're only using 1.8K tokens for that, relevant tokens, because you have only hit the relevant files, which is very important because now think of a saving that you have. It's like 90% of the savings almost there, right? And then plus also you save the less context, again, the output. I mean, you save the inference cost a lot. And product differentiation is because your product is now, it will be, as I said, it's not only the cost, it's about accuracy. Now you're sending more, accurate information to the user, and then user experience will also be much better because now, it can impact the latency also. The less number of tokens that you send, right? It will be able to process this information faster, getting you the information sooner, right? With the low latency, so that it improves the experience. Plus, along with accuracy, it improves the experience. I see Karthik has posted one question, which is, are there examples where the boundaries between these different types of art are blurred? Yes, there could be a lot of examples. So the example that we just saw, right? So semantic plus episodic, both are working together, right? So maybe it'll not work without semantic, right? And maybe it'll not work without episodic. So there could be an overlap, of course, between them. So scenarios where you need an episode as well as you need a semantic mapping there. So that's where the semantic plus episodic both will overlap with each other. Yeah. I hope I answered the question, Karthik. You can ask a follow-up question if you have any questions.
Yeah, Aniket, I have a question.
Yeah.
So this, I have so far only tweaked context memory, but we talk about semantic memory, episodic memory, and procedural memory, right? So, do how does if there is a new skill which is added, does it get added to the procedural memory on its own, or
No. Yeah, we have to add that. We have to prepare the skill, the skill.md file that I talked about, right?
Ah,
So
that's
we
okay.
create the skill every time. It's basically a code that you prepare, which will run on recurring basis.
Okay, fine. Thank
Yeah.
you.
Yes. Is there an architectural difference, or we are leaving LLM to build? No. So in terms of the architectural differences, yeah. So so basically most of the memories, the episodic ones, or let's say the semantic ones. So there is a difference, right? So semantic memory, as we saw, is basically a knowledge graph. It is a part of a graph database versus, let's say, an episodic memory could be part of a normal DB, which is a vector DB, like normal regular vector DB. So in terms of storing, yes, there's an architectural difference then, because graph DB works in different architecture than, let's say, a regular vector DB. So the answer to first part is yes. We don't leave it to the LLM because, as I said, the agentic layer, right, that we have, the programming layer, we have to maintain the cache. So there could be more efficient way of maintaining the cache, or let's say working memory. So the storage of working memory versus, let's say, graph DB, the semantic memory plus episodic memory can be different. So the answer to the question is yes, there could be differences. I mean, there are architectural differences between these memories. So memory is a cost lever. So again, the idea, the purpose of memory is or different implementing different types of memory is to make your agent more efficient from accuracy perspective, from cost perspective, token economics that I talked about, right? And efficiency perspective means like the latency part, because let's say if you're building real-time applications, they have to be really, quick in sending the responses to the user, right? So as I said, like 90, so in this example that we saw, 90% token cost was saved, right? The latency is optimized, right? And then you can have, like, of course, like more efficient way of implementing the whole process, right? So the more cheaper your products become, I gave you the SaaS versus, let's say, AI product SaaS examples. So where you have to be really efficient building the products, and that's why it's more on the cost side or optimization side than on the UX side. It is, of course, a user experience component, but again, user experience comes later. You actually implement this more structure, to implement in a more structured way your agent, right? So again, there could be some trade-offs as well, like quality, latency, and cost, which I think is primarily that, let's say, the more context you provide, there could be scenario, let's say, if you have a re-ranking algorithm which is ranking across the topics that you've retrieved. Take an example of a RAG, right? You can always play with that, like how much documents or records you want to fetch in one time. The more you fetch, there'll be higher chances of recall improvement, right? So then in that case, what happens is that you actually, focusing more on the quality, but at the same time, if you fetch more information, it'll be more cost. It could be more latency also, right? So that way you have to play that. Like, it's again in AI products, right? So the main question is always asked is that, you know, accuracy versus cost, right? So you can, or very simple, like, open source model versus closed source models. So closed source models are expensive but more qualitative in nature, but I mean more quality. But then open source models are less, costly but less accuracy. Oh, so yeah, less accuracy. So basically, again, you pay higher cost accuracy, and then so the trade off I mean, the trade off that works that way, right? So it becomes more costly to become more accurate. So then you need to always like think through like how to manage that, right? So you can't mix all the three. The PM job is choosing the point where, per use case. For example, the coding agent, we want more accuracy. Versus, let's say, if you're building a marketing agent, like marketing content generation agent, you look for more on the cost side, like, rather than quality side, because here you'll be generating a lot of content, and there could be one line which could be irrelevant. In coding, we cannot have that, but in marketing, let's say content generation, we can have that, right? It's okay to be little bit inefficient. Sorry, I mean, yeah. So more, I mean, there could be one or two lines. Generation is fine as long as your latency and cost is optimized. Okay. So yeah. So memories again. Like how you are developing the memory primarily is basically that your memory should be, one is that freshness means like it shouldn't be stale. You have to keep updating your databases, right? Updating the right information, as I said, the way loop works, right, in the example. So you need to keep updating that. How do you check that? Like, what's your mechanism to inspect that? That will also be important, right? And then the way you generate the answers from the memory, the way you fetch this information is like feeling known. So the semantic memory example, right? The way you matches the answer, fetch the answer, is very important. Like, how do you do that? What's your mapping algorithm is? There could be multiple algorithms. What is the best way to fetch the best information that is available, right? So this basically, the idea is that how much control you can have in your hand to, to make your product better. I'll probably skip this one. This is again leakage part, staleness and conflict. Briefly, I talked about it, but I'll come to this in the risk part later. Now, as a PM, what do we need to do? That's very important, right? One is that, like, what is the memory, the types of the memory, right? What exactly, when you're building a product, like what types of memories are applicable? So again, I would go back to that example of, the bug fix agent, and then how do you like implement each type of memory in each of the component. Like, I'll decode the unpack the agent into steps, the workflow that it follows, and in that, where does each of the memory components fit? That's very important, right? Store where, again, vector db, rag, right? Graph db, depends upon what you're solving. We need to store the information wherever it is supposed to be stored, so we have to be a little accurate there. And again, you can collaborate with engineering to get this implementation correctly, right? And the when part is basically that, again, the staleness part, like how much information you need in the recent past. Like, you need 3 months of information, 6 months of information, 2 years of information, right? Based on the, again, quality and cost, you can assess that. The idea is that, since when you need the data, or since when you need the memory, is very important. And how do you want to optimize? Again, implementing by a procedural way, right? How does it work, right? What information to send to view is something that is, again, the control that you have in hand. So these four levers, as a PM, we should use to build a product, which is or platform product, I would say, which is using the memory, right? So all the types of memory, plus the context, and then whole layer of context engineering. Which is, again, so the last slide extension is this one, where the PRDs. I I talk about only high level. So basically, the one is that the overall sources, right, that is available. How are you curating those sources? Like, what's your use case, and how to source those information? How are you collecting those sources and then using them in your product, right? How are you defining the scope, right? Who will own the scope? What should be the retrieval policy? Again, PI information could be there, right? Or how do you fetch the memory part? It depends. Information from the memory, right? Again, freshness of the memory, how much control you want in that. And then security and retention is, how do you share the information? Like, how do you retain the information? What information needs to be retained in the story, the storage is also one of the control that you or one of the layer that you define in your PRDs, right? So it is important, especially when you're building, as I said, the products which are platform-based product. Like, you're building a platform and someone else is coming to your platform and building the application. Let's say you are providing your platform, and then as an agent hub, and people are building the agent. Or let's say you're building a large, task completer agent who completes a lot of tasks there. You need to maintain the memory. The coding example is one. The bug fix example is another one. So you define requirements accordingly. Yeah. So there are like in terms of memory scope in 2026, right? So if you think about, like, there are memory which are native to the models. Claude memory tool, we talked about, right? ChatGPT has their dream memory concept that they have. So LLMs also have the memory, right, of your chat, of your current thread, which means that in the ongoing thread, it will always retain your memory information. Then there are frameworks available which you can use to optimize the memory. As I said, it depends upon your agentic layer, the programming layer, and then plus the DBs that are available, that you can actually store your own information for the long term, let's say, or some episodic memories that you want to store. So these three tools, or you can say frameworks, that you should use, depends upon your requirements of the product. Yeah. Now the question is that, once let's say the platform is ready, from the memory perspective, what you will measure as a metric, right? So one is, again, the precision recall. So recall, as I said in the beginning, right? So fetching the right information, retrieving the right information is the recall, right? So let's say the Singapore July 2026 example. If you're able to fetch the July 2026 exact month and year, you're right in information, right? So right, so that you need to measure. Precision means that whatever you are suggesting, is it getting rightly fetched, right? From, like, whatever query that you're sending, is your query is precise to get this data from the memory. That's basically the precision here. Personalization, task success and without task success with the memory and without memory, right? So let's say coding agent, the example. Now, if you're fetching some episodic memory there, so then with the episodic memory, what is the outcome? What is the code? Versus without the memory, what is the code? You measure the uplift there, right? So and the question then, correction rate is how often it is fixed, when remembered, right? Which means that if you have you know, one second. So yeah. So basically, whenever it has the context, it remembers that. How often users fix that, right? So how frequently you have to fix the code when it comes from the memory. If you are not fixing too many times, which means that you're on the right track, right? And then of course that's a cost part, right? So token per task, the economics that I talked about, like how much tokens you're using efficiently, latency part, and then memory, right? How much you're using, the staleness of the memory. Okay, with that we comes to the end of the discussion, the deck. So context window is RAM, not storage. We talked about it, right? Context engineering is the new core PM craft. Memory is an economic lever, right? It's mainly the cost part and the latency that we optimize for. Trust is which means how do you apply controls on the memory to fetch the right information and all, right? So memory update, right? So or forgetting is a feature, is something that you keep updating your memory, is something that I mean, the overall policy of retention of of the data, or recency of the data is something that you always take the takeaways from.
So one question, Aniket.
Yes.
So when you said that, hey, probably you need to improve your code, and the lesser you are improving, that means your recall is better and all that. So when you're saying improving the code, should I understand that, hey, maybe the way you have architectured the memory is something where you have to improve, or is it like overall architecture, or in which the way you are storing the context, or the way you are storing the data has to be improved? When we so
Yeah.
essentially what I was understanding, hey,
Yeah. Yeah.
because everything is LLM, so we are
So,
relying more on
so
LLM, right?
see what? Yeah, yeah, of course. See, the in the real time, you cannot update the query. So let's say there is a memory system in the backend, and there is a front layer, which is your programming layer, the agent that the customers are interacting to. So think of this like at the real time, they're sending the prompt, and let's say the query is being generated to hit the database, right? So the query you can't fix much. You only update your prompt. So in
Mhm,
the working memory, you can update only your prompt, right? So next time, let's say if you don't find the right answer, next time you try to update the prompt, optimize the prompt, update the prompt, right? So the idea is that why are you updating the prompt? Because let's say if it has to fetch something from the context, right? It should be able to fetch it, or it should be able to hit the right, you can say the point where the information is stored. So that's how you optimize it for. So
so
from
that
your
means the
side,
system prompt, right? Not
this,
the
the user prompt. The system prompt is so okay. There are two parts to it. LM has the system prompt, right? They have. So let's say if you're building your application, yes, you write the system prompt, which becomes the part of the prompt that
Mhm,
LM has. So you can say that your prompt and let's say LM's prompt becomes the overall system prompt. Now
mhm,
your application you're exposing to a user, that will be the user prompt,
mhm,
right? So your prompt, yes, you optimize it so that it hits the right point to fetch the right information. So that is your system prompt, right?
mhm,
Your prompt plus LLM prompt both have to work together, right? Collaborate, and then I mean they get combined, and then let's say user is asking you a question, your user's prompt is taken part of your system prompt, and then send it to the LLM. Correct?
mhm.
So that's one part. Is that clear?
Yeah.
Right. The second is then now, yes. The second part is the now depends upon how the data information is stored in the memory, right? So as I said, there is a short-term memory, there is a long-term memory. There are a few other parts like procedural memory, episodic memory, so on and so forth, right? So these different types of memories are built to again the main purpose of them is to optimize, right? To make your process, the whole process efficient and accurate, right? So let's say you have episodic memory where some same incident happened in the past, and now the query that user has asked is actually matching maybe 90% of that last incident, right? So the 90% information should come from that episode. Given that the episode that you stored is correct, right?
Mm,
That's not wrong. That's relevant to this particular scenario. Now, the 10% information that is not there, right? That was not there in that episode, right? Now you can optimize it. How will you optimize that? You will go back again, update your system prompt to, let's say, update the instruction that, okay, it matches 90% of the episodic memory. Or the other way is that you go to you create a new episode of that memory and stored it as a new incident, right?
mhm,
In the database. So that what happens next time, it is fetching now this episode rather than that episode if let's say similar user query comes. So that's the loop part that I talked about, right? And
mhm,
accordingly, you can update your skill as well, which is your code where let's say you are fetching this information this way, but this information is better fetched if you let's say change your code and there's a new way to fetch that. You update your skill with that particular, let's say the code update or whatever it is, the edit that you have made. Yeah. Does that
mhm.
answer the question?
Yeah, yeah, it does. Like then it's mostly working with the engineering team rather than relying on LLM, right?
Yeah,
Like
yeah, absolutely. Yeah. Yeah. If there are no other questions, then we can wrap up. I will not take more time. Enjoy your weekend. But just would like to, before we drop off, just would like to talk about the program. So I think I said in the beginning as well. So Malti and me are launching this AI PM Accelerator program. So today again was a glimpse of what we want to actually cover, especially in the AI product development, the course that we have. So this course is a blend of both like strategic type of topics that we saw today, right? So how to make the system more efficient. See, token economics is a problem of the leadership. You're actually, now think of this as if you're solving this from your product, from day one, right? You're actually solving a leadership problem, right? So think of this that way. That's more like a strategic point that we wanted to cover. That's one. Second, like one type of content that we cover in the program, in the course. The second is that we have a live hands-on examples, a lot of them, where we actually build agents hands-on. We keep updating our content, the new agents, that new use cases we try to solve, right? Because of course the AI space is growing. Every week we see new models coming, new agents coming. So we want to leverage that as much as we can and try to deliver you know a program which is curated for 4 weeks, which gives you a strong, significant key, takeaways as learnings, in your program, and so that you can apply that in your at your workspace. That's the goal, right? So both is a blend of like product thinking, strategic thinking as in PM, and then some hands-on, because PMs are also supposed to do some hands-on, especially the areas like evals where the job is of a PM is to do really hands-on and test the product end to end, right? So evals, the PRDs that you define, the use cases problem, like solving a business problem to an AI problem, right? So and then some of the LLM concept. We go to more technical and explain you that, so that whenever let's say you start your journey of an AI PM, it actually helps you to get started. There are people who have taken really like who got benefited from this. So hopefully, and we continue to do so. We so so that's the part of the program that we cover. So this program is starting from July 18. You can reach out to Malti. I'll share her number. If you have any questions further about the course, about the details, the fee, and everything, she would be the uh, the right person to talk about that. So I'll just share her number. Please reach out to her. Feel free to reach out to her. Any queries regarding any doubts you have after the course, before the course, during the course, feel free to reach out to her. Yeah, I've shared the number with her, number here of her. So thank you so much for joining.